You'd think they would let you.
All right, so in
bring, like,
number one, the first question, part A, how many zeros are possible? The number of zeros that are possible will be the highest exponent that you see in the problem itself, and our highest exponent that we see here is 4. So how many zeros are possible? 4 zeros are possible. Now, part B, list the possible rational roots. That's going to be where we take our last number that we see and put it over the first number over here. So we're going to have plus or minus 2 over 1. And then we would extend that out. So that's really plus or minus the factors of 2, which is 1, and plus or minus 2. So the factors of 2, 1 and 2. So there's all of our roots. There's a total of 4 there. Part C, we are not going to worry about Descartes' rule of signs. And then part D, we have to find all of the zeros for f of x. So to find all of those zeros, they've gone ahead and given us 2 of them. But remember, there's a total of 4. So we're going to use our synthetic division here, and we're going to pull our coefficients, 1, 1, negative 1, 1, negative 2. And I'm going to use the first zero they gave us, which is positive 1. So a quick reminder, you do drop down that first term. Multiply through, that's going to give you a 1. Combine, you get 2. Multiply, you get 2. Combine, you get 1. Multiply, you get 1. Combine, you get 2, 2, and then 0. And so you know this last 0 there means it's a factor because you did not get a remainder. And so we can even start from this line here, and let's do synthetic division again, and we're going to do that with negative 2. So I'm going to drop us a line, move this down, and so we're going to have negative 2, 0, 0, 1, and then multiplying here we get negative 2 and 0. And again we get that remainder of 0, so we know that negative 2 is a factor. So now we need to write this out. That 1 is really a 1x squared plus a 0x plus 1. And if we fix all of that, that's really x squared plus 1. And we need to somehow come up with a way to factor or solve for x. And with that, we would set this equal to 0. And x squared plus 1 does not factor. So what we're going to have to do with x squared plus 1 is solve this like an equation. So we're going to get x squared, that equals 0. Move this over and get negative 1. Take the square root of both sides, and keep in mind that this is going to be plus or minus the square root of negative 1, and the square root of negative 1 is going to be plus or minus I. So whenever we're listing out our zeros here, because we found them all now, the zeros that we found would be plus or minus I, so there's 2 there, and then 1 and negative 2. All right, so our next problem, we had to graph this equation here, and hopefully when you graphed it, you got something that looked like this. And your local maximum is going to be up here, local minimum somewhere down here. And those values, you should have gotten 1.28 and 12.3. And then your minimum point, hopefully, you got 3.39. and 7.58. And then over here to the side, it wants to know your max value, and keep in mind these are going to be your y values. Your maximum value is 12.3, and again that's y value. And your minimum value, that's going to be 7.58. And then you need to find your x-intercept. And again, we can do all this on our calculators. That x-intercept value is going to be negative 0.325, comma 0. All right, and so for our next one, this is cubic, and it wants us to use limits to describe our end behavior. So a cubic function, just keeping in mind, a cubic function does something like this. So if we're talking about our limits, then the limit as x approaches negative infinity of our function is going to be negative infinity if you're approaching negative infinity. And then the limit as x approaches positive infinity of the function is going to be positive infinity. All right, write a cubic function with the given zeros. So with these zeros, like they're given, we have to work backwards. So what we're going to do with these, I'm going to say x equals root 2. Well, before that, this said x minus root 2 equals 0. And this one would have been x plus root 2 equals 0. And then the last one would have been x minus 3 equals 0. And then putting all of those together, we have x minus root 2, and then it would have been times x plus root 2, and then x minus 3. And then all of that equals 0. Now you're going to multiply these first two, so that's going to give me x squared. And then if I multiply the outer and the inner, those are going to cancel each other out. And then multiply the last, that's going to give me minus 2. So that's the first two parentheses multiplied together. And then bring down your next. So we're going to bring this down and multiply it. So now let's multiply out. We're going to get x cubed, and then minus 3x squared, minus 2x, and then plus 6. And that's going to be our cubic function that we're looking for here. All right, so for number 5, we've gotten 1 0, and they want us to find the other 0. So the other two zeros, and I know we have a total of 3 zeros here, so we have to be careful with all of them, trying to find what we're going to need. So we have 1 minus root 3. So if 1 minus, not root 3, 1 minus 3 has a root, then I automatically know 1 plus 3i is a root. They're always in pairs. And then we've got to find the last one. So we go back to synthetic division, and we've got 1, negative 7, 20, and negative 50. And then we've got to go through and find all of our factors of 50. So those factors of 50 are 1 and 50, 2 and 25, 3, 4, 5, and 10. And I would not choose these larger numbers because of the 20 and the 50. So it looks like 5 or 10, and I would pick 5 because it's just a good middle number. And so we're going to drop our 1. So 5 times 1 is 5. Put those together, you're going to get -2. So that's going to give us -10, which is 10. And then that's going to give us 50. So we chose right. Yay. And we know we've chosen correctly because that remainder is 0. So our other 0 is a 5. Now our linear factorization is just putting this together in parentheses. So we're going to say x minus 5. We're going to say x minus 1 minus 3i. And then x minus 1 plus 3i. All right, moving on. Number 6, find the quotient and remainder when f of x is divided by g of x. And then is g of x a factor? So we can use our synthetic division here. So we have 2, 8, -5, +5. And remember, when it's in this form, we say x minus 2 equals 0. So x equals 2, and that's what we go through and divide by. So we're going to drop our 2. So it's going to give us 4. So 12, 24, 19, 38, and then 43. So our remainder is not 0, so that tells me that g is not a factor. So let's see what we have left over, because it does tell us to find the quotient and the remainder. So we were at x cubed, we divided out an x, so we're at x squared. So this is going to be 2x squared plus 12x plus 19 plus our remainder, so 43 over what we were dividing by, which is x minus 2. And then is g a factor? We're going to write g is not a factor. All right, problem 7 and 8. We have a lot of different things to do with those. We have some graphs here. And so they've already given us our intercepts, which is nice. The first thing they want us to do in part A is find the x and y intercepts. So for part A, you should get x equals 2 and x equals -4. And then for part B, determine if it touches or crosses the x-axis at each x-intercept. So for part B, you're going to touch at 2. And then cross at 4. C, write the end behavior using limits. So we're going to say the limit, that was strange. So we're going to say the limit as x approaches -infinity of f of x equals -infinity. And then the limit as x approaches +infinity of f of x equals positive infinity. Part D, determine the maximum number of turning points. This looks like it should have 2. Part E, use the x and y intercepts to find the intervals in which the graph is above or below. So for part E, f of x is above or positive above over the intervals from -4 to or from 2 to 0. And then below, f of x is below on -infinity to -4. All right, and then we need to plot the points and do a sketch. So, let's see, a good sketch. Looks something like that. Let's see, you've got a point here at -4, 0, up here at 0, 16, and then down here, of course, this isn't drawn to scale, goodness, 2, 0. All right. Number 8, part A. You should have x equals 1, x equals -3, and x equals -1. Part B, we're going to cross at -3 and 1, -1. And then we're just going to touch at x equals 2. No, they had that wrong. Then it's just going to touch at x equals 1. She had that wrong. All right, part C. K are in behaviors. This is an odd function or even function. This is an even function, so the limit as x approaches -infinity of f of x is going to be positive infinity, and the limit as x approaches positive infinity of f of x is positive infinity. Part D, how many turns will this have? It should have 3 turns. And part E, we are positive over the intervals from -infinity to 3.
Jacob Golden, please come to the main office. Jacob Golden to the main office.
-1 to 1, or 1 to infinity. And then below the x-axis from -3 to -1. All right, so a sketch of this, we have -3, -1, +1. Something like that. Alrighty. Okay, so for the next one, number 9, what you will need to do is to graph. You need to graph both functions. Graph s at p and d at p, and then find where they intersect. Find the intersection of those. And you should end up with a value of $96.24. All right, number 10. With this one, it looks like here you start out with multiplying by the least common denominator. And that least common denominator is going to be 42. So I'm going to multiply every single part by 42. Okay, so multiplying that by 42, the first one you're going to get 6x plus 24, then minus 7x plus 35 equals 168. Now combining everything together, you get a negative x equals 109. So x is 109, negative 109. Okay, over on this other side, the least common denominator is 4x. So we're going to multiply every single term by 4x. Okay, once we do that, we are going to have 20 minus 4x plus 3x and then that's going to be equal to 28. And so that's going to give you negative x equals 8. So x equals negative 8. Okay, so the next one, here we're going to go through and list out all this information. First thing you need to do, though, is to try to factor. So we've got x minus 1 times x minus 1 over x minus 1 times x plus 1. All right, and so those x minus 1's cancel. So I have an x minus 1 over an x plus 1. And let's list out all of our stuff. So A, factor and simplify and rewrite. So r at x is going to be x minus 1 over x plus 1. Part B is going to be y equals 1. Part C is going to be x equals negative 1. Part D is going to be 1, 0. Part E, 0, negative 1. Part F. Part F is going to be 1, 0. We've got a hole. Remember, the holes are generated from where you've canceled, and then you go back and plug into the reduced form to get the y value. And then, let's see, G is going to be determine where the graph is above and below. So here the graph arcx is above from negative infinity to negative 1. And 1 to infinity. And then below, the function is below the x-axis from negative 1 to 1. And let's do a sketch. Remember, you have got your asymptotes. You've got at x equals negative 1. We'll put that in. And we also have horizontal asymptote. And then we've also got 0, negative 1. And then we've got a hole at 1, 0. So it looks like we've got part of our graph that's going to go this way. And then our other portion, remember, it can't run parallel, so it's going to be up here. So there's all the pieces of our graph. Okay, same thing on our next one, number 13. Going to be working through. And again, we try to factor. So this top part is going to be x plus 4 times x minus 4. And then the bottom is going to be x plus 2. All right, and so let's start by going through the questions here again. So our reduced form, this is a part. That's about all you can get from it. So for part B, we're going to have y equals x minus 2. Let's see, what was part B? That's going to be a slant asymptote. So to get our slant asymptote, remember we do long division with that. So let's go over here to the side and look at it. We're going to say x plus 2 will divide into, and we've got x squared. We need to add a 0x and then minus 16. And so we're going to have an x, multiply that through, and you get x squared plus 2x. Then you're going to subtract those. So you get negative 2x minus 16. And then multiply here a negative 2 and negative 2x minus 4. And then that's all you worry about. So right there's your slant asymptote. That's where that came from. Okay, part C, you should have gotten x equals negative 2. Part D, you should get negative 4, 0 and positive 4, 0. Part E, got 0, negative 8. F is no. Part G, so our function is above the x-axis or positive. From negative 4, negative 2, and 4 to infinity. And then negative, whenever we have negative infinity to negative 4, or negative 2 to 4. And then sketching this, remember you've got a vertical asymptote And then you had a horizontal one, -2. Because that's definitely not a straight line. And then we have -4, 0. So this is going to bend out this way. And then we had 4, 0. And then 0, -8. So there's our other one. All right, number 14. So we have model parabolic motion, a ball being bounced straight up into the air with the initial velocity and initial height. What is the maximum height that the ball will reach? All right, so let's fill in what we were given. So we have initial velocity is 15 feet per second. And then we were also told that the initial height was 3 feet. So let's fill in. This is a great calculator problem. So we fill in our position function. It's going to be -16t squared plus 15t plus 3. And now what we're going to do with this is we need to find our maximum height that the ball will reach. So what you can do is graph this and find the maximum. And you should get your max height to be 6.52. All right, so again, a great calculator problem. All right, number 15, determine the x values that cause the polynomial function to be a 0, b positive, c negative. All right, so let's look. We can pull these from the number line here. And notice this is going to generate for us a -2, -1, and a +1. So let's put these on the number line. -2, -1, +1. So for our polynomial to be 0, so for our 0 value, that's going to be -2, -1, and 1. So for part B, positive. This is where we pick our test points and see, well, where are we going to get a positive value? So let's pick out some values. Let's see, let's pick -3 out here. That's a good one to pick. And so if I plug in -3, I'm going to get a negative times a negative times a negative. So that's a negative out here. What about between -2 and -1? Let's say -1.5. And so that's going to give me a positive times a negative times a negative. So that's going to give me a positive through there. And then I'm going to pick 0 out here. If I plug in 0, I get a positive times a negative. And then on the other side, let's pick 2. And 2 is going to give us positives. All right, so now we can see, where do we get positives? Well, between -2 and -1, and from 1 to infinity. And then part C, negatives, Well, where do we get negative values from? Well, that was from negative infinity to negative 2. And where else did I have a negative? From negative 1 to positive 1. All right. Okay, number 16, we're solving this inequality. So it's going to be the same thing again. We're going to pull this value negative 10, negative 8, and 6. And so with this, we're going to put these on the number line. We've got negative 10, negative 8, and positive 6. And we need to see where we're at as far as positives and negatives. So on the other side of negative 10, let's pick negative 11. So if I pick negative 11 and plug in, I get a negative, and a negative. So that's all negative. But I need positive, so it's not going to work. So let's go to negative 10 to 8, pick negative 9. That's going to give me a positive times a negative times a negative. So that's positive. So I know that interval is going to work. From negative 8 to 6, let's pick 0. That's going to give me a positive times a negative, which is negative. And then on the other side of 6, let's try 7. And that's going to give me all positive. So I know that works. So from negative 10 to negative 8, and from 6 to infinity. Those work. So for number 17, we're solving the inequality. And so for this one, it's not in factored form, so we're going to have to do some kind of factoring first. So we're going to do 3x and x. And we've got to get a negative 2 out of this. So I guess we could do 1 and 1, right? We'll need a negative 3 and a positive 1. And hopefully that'll generate a negative 2 for us. I believe it does. And then from there, we go to the number line and look at our values that we get. We're going to get a negative 1/3. And we're going to get a positive 1. And again, we need to choose some numbers inside there and plug in to satisfy the inequality, what's going to make us greater than or equal to 0. So, or equal to 0, so we know we're going to have some closed-in values here. And so first thing I would pick would be right here at 0. So let's plug in a 0, and I'm going to get a 1 times a negative 1. So those are all going to be negative inside there. And that negative is not going to comply with our being greater than or equal to 0. So that's not going to work. Okay, since that was the negative, let's go on the other side. Let's pick something out here. Let's say, what, negative 2 maybe? Be a good number to pick. So plugging in there, negative 2, that's going to give us a negative from the first parentheses times a negative, which is a positive, which is what we need. We need that because that's going to be greater than or equal to 0. So I know out through here is going to work. And then we need to also check on this other side. Maybe pick a positive 2. So if I pick a positive 2 on this outside and plug in, that's going to give me a positive times a positive, which is again a positive. So that's going to be that side as well. So we could say from negative infinity up to negative 1/3, and that's going to be a bracket. And then we could say, and over on this other side from 1 to infinity. All right, now solving our inequalities. With the inequalities, this is where we went through and set the top, or no, we set the bottom equal to 0, didn't we? So we said 2x plus 5 equals 0. We found that point of discontinuity. So then that's going to give us x equals negative 5 over 2. So there's 1 point. And then the other one, we set up some kind of proportion. We said 3 minus 2x over 2x plus 5 equals 5 over 1. And that's where we cross multiplied. So we get 3 minus 2x equals 10x plus 25. Okay, and then that's where we move everything over. Let's see, I'm going to move over the 2x. So if I do that, that's going to give me 12x. And then over on this other side, if I move over 25, that's going to be negative 22. Divide by 12. So x is going to be negative 11 over 6. So let's look at these. What's 11 over 6? That's going to be what? 1 and... Oh, my pen stopped working. Negative 1 and 5/6. And this is negative 2.5. Put that on the number line. So we've got negative 11 over 6, or negative 1 and 5/6. And then we've got negative 2.5. I'm going to run way over here and pick 0. A nice number to pick. So if I plug in 0, do I get a true statement? I get 3 over 5, don't I? Back up here. Is 3 over 5 bigger than? I'm not going to get a true statement with that if I plug it in. So that's not going to work. So if that interval doesn't work, I bet this interval out here doesn't work. So which interval is probably going to work? This one right here. And we can pick a point inside that and check it and see, but they are alternating, and y'all are starting to see that. So there's your interval. So we're going to say, oops. We're going to do parentheses, negative 2.5, comma, negative 1 and 5/6, with the bracket. So it is included. If you left it on the number line, open circle and close circle it. And I don't care which one you do, whether you leave it on the number line or put it in interval notation. All right, number 19. Let's go ahead and factor that. So you've got x minus 6 times x minus 2 over x minus 4 times x plus 4. And all of that's greater than 0. Oh, gracious. So, since all that's greater than 0, that endpoint being 0, you just put all of those, set them equal to 0, and put all those points on the number line. So, you're going to have a 6, you've got a 2, you've got a 4, and a negative 4. So, we've got negative 4. We've got 2, 4, and 6. All right, so picking some values, I would pick a 0, just out of the weirdness. If we plug in a 0, I get negative times a negative, so it's a positive, over a negative times a positive, so a negative. So that's going to be negatives. Well, that's not going to work because I need positives. So let's try on the outside of negative 4. Let's try negative 5. So that's going to give me a negative times a negative. So that's a positive over negative times a positive, which is a did I do something wrong? This should alternate. Nothing's repeating. All right, so negative 5, negative, negative, positive, negative. Oh, negative and negative is a positive. Duh. Good grief. So that is a positive, so that interval does work, which is what it's supposed to do. So that interval works. This interval from negative 4 to 2 didn't work. So guess what from 2 to 4? That one should work. Then the interval from 4 to 6 is not going to work. And then the interval past 6 should work. All right, so listing this in interval notation, negative infinity to negative 4, parentheses, there's no or equal to up here. And then you've got from 2 to 4, and then 6 to infinity. So for number 20, which graphs have the domain negative 2 to infinity and 2 to infinity? They have A and B. So for the next one, number 21, so write the domain of the graph of C in interval notation. So they have from negative infinity to 2, union 2 to 3, union 3 to infinity. Okay. Number 22, write the domain of the graph of D in interval notation. So that's going to be negative infinity to negative 2, union, negative 2 to 2, union, 2 to infinity. Okay, number 23, which of the graphs have a range from 2 to infinity? That's going to be A. Number 24, which graphs have a range from negative infinity to positive infinity? That's going to be D. Number 25, state the range of the function of graph C. So that's going to be negative infinity to 2, union 2 to 3, and then union 3 to infinity. Number 26, if f represents a function which choices have a single solution, okay, so that's going to be B and C. Number 27, A and D. And 28, here the graph of D such x value such that f of x equals 0, so x is going to be 0 there. Here we're going to get from negative infinity to negative 2, union 0 to 2. And part C, you're going to get from negative 2 to 0 included, union 2 to infinity.